If two events are independent, then we have a simpler multiplication rule, that the probability of A and B simply equals the product of each of their probabilities. But remember, this only applies to independent events. In an earlier section, we talked about the probability of A and B, a multiplication rule, but we weren't dealing with independent events, so don't get them confused. So here we have many people who visit clinics to be tested for HIV, the virus that causes AIDS, don't come back to learn their test results. Clinics now use rapid HIV tests that give a result while the client waits. And a clinic use of rapid tests increased the percentage of clients who learn their test results from 69% to over 99%. The trade-off for fast results is that rapid tests are less accurate than slowly laboratory tests. Applied to people who have no HIV antibodies, one rapid test has a probability of about 0.004 of producing a false positive. If a clinic tests 200 randomly selected people who are free of HIV antibodies, what is the probability that at least one false positive will occur? Assume that the test results for different individuals are independent. So it's key here that it tells us they're independent, but we can also assume that each test would be independent of another because we're trying them on different individuals. So if we're looking at the probability of no false positives, that's the same thing as saying the probability that all 200 tests are negative. So it already told us that one rapid test has a probability of about 0.004 of producing a false positive. So then a actual positive, or a negative, would be 0.996. So 200 of them, 0.996 times itself 200 times, or just with an exponent of 200, would be 0.4486. So we want the probability of at least one false positive. So if 0.4486 is the probability of all of them being negative, then 1 minus this would give us if one was false positive, if two were false positive. This is the perfect example where the complement rule is much more efficient than than adding all the things we actually want. To find the probability of at least one false positive, you'd have to calculate the probability that there was one false positive. Then you'd have to add in the probability that there were two, add in the probability that there are three, so on and so forth until you get up to 200. So you'd have 200 probabilities to calculate. Or if we look at the complement and saying that there are no false positives, this is the complement, that's easier to calculate. Then just subtract it from 1. So the probability that at least one test comes back as a false positive is 0.5514.